A series of sessions for building capacity in certain skills that we think will be really useful to you when you either attend the annual scientific symposium next month or just more generally in your research career. So the one today is for peer review and peer feedback, which are skills that we would like you to employ at the annual scientific meeting and which are essential for you to employ in your research careers. But here at the end of the session, you'll be able to both define peer feedback and peer review, engage in those processes, and also really gain a depth of understanding in terms of why peer review is important in terms of contributing to scientific integrity and quality assurance. As scientists, it's unusual in comparison to many other fields where we essentially monitor and regulate each other in the work that we produce. So we very much operate on a trust-based system, and peer review is really the cornerstone of that trust-based system. So we keep each other in check. So we'll start with peer feedback. This necessarily needs to be constructive, but it can also be very informal. So really, when we're asking for feedback, what we're asking is, how can I do better? Or can you identify ways for me that I can improve my work? So it's really focused on that spectrum of improvement rather than a formal evaluation. It can be useful in building collaboration and reflective practice, which is why we're really encouraging you to engage in this at the annual scientific meeting, because it can be a useful way to highlight to colleagues what you think they've done well and what you think they could potentially improve on to strengthen their work and then ultimately the work of our centre, so it benefits us all. And there are numerous ways that you can provide this feedback, depending on the setting that you're in, your own preference, the preference of the person or group that you're providing feedback to. And that can be verbal, written, synchronous, being at the time somebody presents you with something. So maybe they're giving a presentation and immediately after you say, yep, that was great for this, but you could do better in this. Or asynchronous, which means that they might submit a piece of written work to you or send you an outline of something they're working on, and you can review it in your own time and send it back to them at a later date. So there are some practical tips that we want to impart to you in order to make sure that the peer feedback that you give is effective. So the number one element of this is really to be specific and focus on concrete elements of the work. And this allows the person or group you're providing feedback to really identify the area within their work that they need to improve on and how they can do that. So it's always worth balancing strengths and suggestions for improvement. You don't want to just really pick apart somebody's work because obviously it would leave them feeling quite deflated. And it's not very nice when that happens. So as feedback is an informal mechanism, you tend to only do that to the colleagues with whom you work, and therefore you want to keep them on side and be kind. So just remember people's feelings when you're engaging in this process as well. But balance those strengths with things that they could do better. Use I statements. So say, I think that you've written this part really well, but maybe this last sentence could be strengthened by adding more information on whatever it may be. And you can also ask a lot of questions rather than making assumptions. So have you thought about including a comparator? Have you thought about an additional case study with another context? You know, these kind of questions aren't you necessarily saying something is good or bad, but they're encouraging your peer to have a dialogue with you and with themselves in the research to think about ways in which they might like to do things differently. So these kind of questions are a really useful way, and I'm sure many of your mentors and supervisors have engaged in this kind of feedback with you already. So that nobody can forget, this is a very simple three-step process that I've put here, which essentially boils down to observe, comment, and support. So you're observing the work, whether that be written, verbal, or a combination of the two. You're making some comment, as we say, about the strengths as well as the areas of improvement. And when you're doing that, it's also a really nice thing to be able to do where you say, if you'd like me to show you how I've done this before, let me know. Or as I've suggested, you might want to add a case study. Let me know if you want some help working on that case study. Or I know PhDs are really difficult. I'm always here for a chat if you are at your wit's end. As peer feedback is a collaborative and supportive process, it is worth really putting being kind and supportive at the center of that process. It's not always nice to receive feedback, especially if that feedback is negative, which is why we're really proposing in this feedback mechanism that we'd like to start implementing at the GHRC to ensure that it is constructive feedback that we're giving, that it is useful, and that it's not detrimentally impacting any of our researchers' mental health or confidence in the research that they're producing. We are all learning together. We're all building expertise and skills, albeit at different levels. And we must never forget that ultimately we're all in it for the same reasons and we're supporting each other as we navigate this journey. So, as an example, you could say your introduction's clear, maybe add a bit more context for non-experts. And this is something that I see all the time where things can be very much, when you're doing your PhD or your postdoctoral studies or your master's thesis, you really are the expert in your field. And it's easy to forget that not everybody else knows what you're talking about. So having this kind of feedback is a very common comment that I see. Or as we mentioned the question method, you could say things like, would color labels maybe help improve readability? Or can you explain why you chose this method a bit more? Could you expand the evidence base? These are all useful questions that aren't really commenting on whether the work is good or bad. They're just stimulating conversation and thought to improve the work. So I'll pause in case anybody has any questions on peer feedback before we move into peer review. Please do just speak out or put anything in the chat. Great. Okay, we'll move on to peer review. So peer review is a slightly more formal process in academia. And as I say, as we operate in a very much trust-based system, peer review is an essential component of quality control in academic publishing, but also in academic output generation, whether that be a formal paper, perhaps a blog that we might put on a journal website or our own website with the ability for others to comment. Usually those comments relate to the scientific integrity or question some of the work that may be outlined in that blog. Sometimes those comments become negative and we have to turn them off, but if we really focus on constructive peer review, that's what this process is for in quality controlling academic outputs. So it ensures validity, originality, and clarity of research. And it's conducted by experts in the field. And I think that when you're at an early to mid-career stage, it's often easy to forget that you are the experts in your field. You have just as much right to be engaging in this peer review process and contributing to the greater good of scientific integrity and quality control as your seniors or superiors. And it's really a great way to build your own research quality and integrity by engaging in this process early in your career, because it helps you shape your thoughts and ideas around how you need to be writing, producing your own research outputs and the kinds of things that you need to do when you're conceptualizing your study, when you're looking at different types of data and analysis, and the way that you write that up to ensure that it's clear. So as I say, why do we do peer review? It ultimately improves scientific rigor. It prevents the dissemination of flawed research, most often, and it builds credibility for authors and journals. So, two very prominent examples of when peer review haven't worked are the publication by The Lancet of the falsified data for a causal link between the MMR vaccine and autism. This paper did undergo peer review. However, it was known later that the peer reviewers themselves were known to the scientific authorship committee, that the data wasn't provided, so it couldn't be verified, and that the peer review process had essentially failed because the peer reviewers didn't comment on a number of very important omissions from that research study. So it has been known for decades now that the research within that paper was completely falsified. However, it remains having a highly detrimental impact on the immunization of young children against measles, mumps, and rubella due to a completely unfounded fear of its links to autism. So this is an example where peer review went wrong because the peer reviewers themselves weren't engaging in scientifically rigorous peer review. Also, that the authors of that paper had engaged in scientific misconduct. There was also a more recent example where during the COVID-19 pandemic, the peer review process was warped. And I don't know if anyone on this meeting was involved in peer review of COVID-19 literature or contributing to that literature. But what essentially happened was that the scientific community at large agreed on somewhat of an amnesty to peer review, where in the favor of getting out emerging research as quickly as possible, the peer review process was often suspended such that papers could be published as preprints, and those preprints were then often taken as peer-reviewed literature, even though in order to be published as a preprint publication, it was not peer-reviewed, and that meant that a number of papers, including one study that promoted the use of ivermectin for treating COVID-19, which again was found to be completely falsified, got through the scientific rigor net and caused a great deal of damage. So while we've retained somewhat of a database of preprint publications and a number of scientific researchers and publications still have a preprint platform, there are much more stringent regulations now about preprint needing to be very clearly and transparently labeled as such, and that it has not undergone peer review, and for those preprints to then undergo a peer review process. Otherwise, certain platforms remove the preprints if they no longer meet their criteria for scientific rigor. So it's a really, really important process that we can all contribute for improving scientific rigor. There are a number of ways, and every journal or academic outlet tends to have different processes for peer review. These can be single blind, double blind, or open peer review. So single blind means that one party knows who is reviewing and the other does not, or you don't know who the authors of the study are. The other is that you don't know who the authors are and the authors don't know who you are. And that tends to be the most common process now, so that we can avoid conflict of interest. There is also open peer review, where you know whose paper you're reviewing. They can ask you to review it so they know who you are. And then there's transparency about whether there are any conflicts of interest. So your responsibility as a peer reviewer is to provide objective, constructive feedback. You're evaluating the paper in its entirety, or the output, whatever it may be. So you're looking at the methodology and whether that was sound, warranted, and aligned with best practice within whatever your field may be. Whether the analysis used the correct statistical methods to understand and unpack the data. Whether the interpretation of those results was accurate and correct. You're also assessing novelty and contribution to the field. So you are providing a feedback to the journal editor to say, I think this is a really important paper in the field. I think it's addressing an unknown research question or a gap in the evidence or literature, and it's your duty as a peer reviewer to make a comment on that to help inform the editor decision about whether they publish or not. You're also ensuring ethical standards are met. So it's your duty as a peer reviewer to make sure that ethical clearance was granted and that the research was conducted in an ethically sound way. So when you are engaging in peer review, you first have a quick skim of the paper to make sure that its scope and relevance are within your area of expertise. If it is not, you should not be reviewing a paper that you don't feel that you can adequately assess for scientific rigor. And it's very, very common that you will get sent a range of papers, many of which are outside your expertise. And all you need to do is tell the editor, no, I cannot review this paper. And often they will ask you for a reason. Once you've recognized that it's within your scope and relevance, you read the paper far more closely and you start to take structured notes. So I like to start with the introduction, making bullet point notes about every paragraph. What is great, what could be improved upon, and you give very detailed feedback in terms of the paragraph and the line number and the page number for every single bullet that you denote. You're then evaluating the methods, the results, the interpretation of that, making sure that all of that is clear, that you understand it, that it's scientifically sound, and that no other analyses is required to be done, no other covariates within the analysis, no other statistical methodology that should have been incorporated. And you're making comments as you go, again in bullet points, referring to the page, the paragraph, and the line number of each of the points at which you would like the authors of the study to address. You often are required to write a final paragraph around generally your interpretation of the paper, its scientific contribution to novelty, its clarity, its use of scientific language, the way that it's organized and presented. And then you're also making sure that citations and context are accurate. This didn't used to be such an issue, but in the age of the prevalent use of artificial intelligence and hallucinations by those artificial intelligence bots, it's a very increasingly common phenomena for authors to be submitting papers with citations to articles that have never been published. And that's a very clear indicator that the paper wasn't written by the author. It was written by an AI model and therefore would be a major red flag for a journal and for the authors not being able to comment on the scientific integrity and novelty of that work if they have not written it themselves. So you can also be blacklisted from journals for doing this and not declaring how you've used AI in your studies. So it's something that if you are using AI, you need to be very, very careful of. And then you go on to really look at, is the study design appropriate? If you drill down in a practical example, you're asking, are the methods reproducible? Are the sample sizes justified? Is statistical analyses appropriate? And it's important to note here, if you are not a statistician and statistics is not your strong suit, don't feel like you need to be studying statistics in order to make peer-reviewed comments about the statistics. You need to know enough to know whether the methods look right to you and if the interpretation is correct. If it is a complex statistical heavy paper, you can absolutely write a comment to the editor to say, I am not a statistician, I am a XYZ, whatever your field may be. Therefore, I have concentrated my peer review comments on these sections, and I would like to request that a statistician properly review the statistics section. And a number of journals allow you to do this and have additional peer review purely for the statistical methods. So don't feel afraid to outline what your strengths are and what your weaknesses are as a peer reviewer. And I think the best peer reviewers do that with confidence and don't pretend to be experts in areas that they are not. It's important to look at results and first of all, assess, do they make sense? Can I understand what this paper is trying to tell me? Have they accurately used figures and tables to communicate the information and do all the numbers add up? It's really surprising how often a paper goes through peer review and I, as an editor of a number of journals, will see that they've listed a sample size and then disaggregated their data by different population groups, and it doesn't equal to the sample size number. They've made basic mathematical calculation errors. So it's important as a peer reviewer for you to check things like this. And then looking at the conclusions, a lot of the time science doesn't go the way that we hoped it would, and our hypotheses aren't supported by the data. Numerous authors try and still wrangle their data into a way in which they think that it could potentially be interpreted as meeting their hypothesis, perhaps not as strongly as they'd hoped. But what you need to do as a peer reviewer is really ask, are these results supporting the conclusions the authors have made? Is this really as important as the authors are saying it is? Is it really as strong a signal as they are claiming? And is it really as novel, as important, and as a valuable scientific contribution as the authors are telling me that it is? A lot of the time, the answer is no. And it's important to recognize here that there is a perverse incentive for authors to really speak in grandiose terms about the importance of their findings and how novel their paper is, because they need that paper to be published in order to further their own scientific career. So it's a very perverse model for incentivizing bad behavior, or at least not scientifically robust behavior at all times when you need those papers. They say publish or perish as an academic, and that is very much felt by numerous peers in our field. So it's worth looking out for as a peer reviewer. As I say, this overgeneralization of results is really common, and there are a number of reasons behind it, but it's something you need to go into every peer review understanding and looking for. So a lack of methodological detail can sometimes be obfuscating or hiding what has truly happened. Statistical errors could indicate that you just have no confidence in all of the results that have been produced, not just the ones that you can see clear errors in, because it undermines the credibility of the entirety of the research if there are errors in the smallest results presented that you can notice. And also, if there are these grandiose, unsupported claims being made, it again really makes you question the entirety of the paper and whether or not it should be published. So when you're writing this feedback, it's important to be very, very specific, as I say, for every bullet point that you're drafting where the authors need to improve. You're giving the page number, the paragraph number, and the line number, and saying, this line is incorrect. Please address this error. Or there is no background information on this phenomena the author is talking about. Please provide more information. You're being very, very specific about both the issue that needs to be addressed and how you would like it addressed. You avoid personal tone, so this is very different to peer feedback. You're being very impersonal and professional in your tone, using third person often. So the author stipulates this, the peer reviewer would like to see X. And then you also can organize your comments. So these comments tend to be organized in terms of major revisions that need to be undertaken. And these are things like additional statistical tests, a revision of the entire framework that's been used to analyze or synthesize results, or minor. And these are things like typos, spelling mistakes, a bit of extra information that's needed in certain sections, or a fixing of some typographical errors or formatting of a paper. So at the very beginning, we talked about the different kinds of peer review you can do, single blind, double blind, or open. It's really important, whatever the kind of peer review you're engaging in, that you do declare your conflict of interest. As my field is health economics and policy, and I've worked in it for over a decade now, I know a lot of my peers working in similar fields to me, and this happens for everyone, meaning that the papers that get sent to you are often from your collaborators or friends. And so that is a conflict of interest that you should declare, because you cannot be impartial when you want to see your friends and colleagues succeed. You should not use unpublished data to support any claims that you are making, and you should also be timely and professional. So journals will often give you a 2 to 3 week window to submit back your peer review. If you require longer than that, it's usually a pretty simple process to request another week or two, and journals will almost always grant you that, but you need to be communicating with them about those time requirements. And there are also some tools that you can use to help you engage in effective peer review. So in the same way that when you're reviewing your own work and going through risk of bias assessment or quality control, you can use the same reporting guidelines to check through other papers that you might be reviewing. So these are guidelines like the PRISMA guidelines or the consort guidelines for RCTs. You also will need to check the journal's specific reviewer instructions, and whatever journal you're reviewing for will have instructions for you to follow. And then, as we said at the very, very beginning with peer feedback, peer review ultimately has the same aim, which is to support authors and peers in the scientific field to improve their science and research. So the consort checklist gives you some really useful guidelines for how clinical trials should be structured and reported. These are things like the type of design that a study is used, whether they have engaged in randomization or not, blinding, what the intervention shape is like, how participants might move through a clinical cascade or be recruited. And all of these kind of aspects are really important to the integrity of an RCT. And so using the consort guidelines is a great way for you to be able to peer review other RCTs that you might be sent for review. Similarly, the PRISMA guidelines, which I'm sure most of you have used to inform your own systematic reviews, can also serve as a really useful basis for reviewing other people's systematic reviews and meta-analyses. So there are a number of components to these PRISMA guidelines. In terms of search strategy, the number of sources used and the quality of those resources, study selection and how inclusion and exclusion criteria were defined, whether a risk of bias was done, how results were interpreted and synthesized. So again, if you're looking to peer review a systematic review, I would be looking at the PRISMA guidelines in the first instance to guide your own review of those reviews. So as we had with the peer feedback, I've got 3 really simple step process here for peer review. Input, review, and output. So the input is the piece of academic literature that you are required or asked to peer review. You take that on board and review it. And then finally, you yourself produce an output. And that output is a peer review report. Within that report, you have a general statement about how good you think the paper is. That usually is private only to the editor. You then have your very detailed list of bullet points where you outline every single line within the paper that you would like to see addressed and how you would like to see it addressed. And then you provide a conclusion statement where you ultimately make a recommendation or not for that paper to be published with either minor reviews, minor amendments, major amendments, or not publishable. And the criteria for making these decisions does differ somewhat depending on what the journal is. So as you can imagine, the New England Journal of Medicine or the Lancet have very, very, very high standards for what gets published in their journals. That's slightly different to lower impact factor journals, although the principles remain the same. So in terms of practicing this between now and the annual scientific meeting, I would encourage you to share a piece of writing or present your work to a colleague. Maybe you have a conference coming up and you want to practice. You might have an exam for your PhD. You might be about to submit a paper to your mentor or supervisor or to a journal, and you want to get some feedback before you do that. Ask them to review your work and offer to do the same for them, because both getting peer feedback and generating peer feedback is beneficial to your career. You're building skills, expertise, and knowledge that are going to be essential for your future in academia and beyond. I would encourage everyone to sign up for an ORCID. And this is a unique identifier for every researcher that is attached to all your publications, but importantly, goes as an ID to every single peer-reviewed journal within your field so that they can invite you to peer review. I would also really suggest that you raise your hand and speak to colleagues and your supervisors, mentors, and tell them that you're interested in engaging in peer review. And so that when they get sent papers to peer review, if they can't do that or don't want to, they're able to send your name and email instead. And usually, once your name is on a database, you will then start to receive your own requests for peer review from journals. You can also sign up to be an assessor for fellowships, awards, or grant schemes. And this is a really good idea because it both helps you see behind the curtain in terms of how your own work is assessed and therefore how you can improve your work. But it also allows you to start to build an understanding of your competitors in the field and what kind of work they're doing, of working with assessment panels and getting a better feel for what tends to be funded or published and what doesn't. And it really also is a great thing to be able to put on your CV when you apply for your own fellowship awards or grants, because it's something that almost all schemes consider as a contribution to the scientific field that you are required to report on as part of your application. So it's a really good and easy way to start to build some credibility and momentum in that aspect that's important for when you're submitting your own opportunities. And then finally, volunteer. We've got a number of opportunities across the Global Health Research Centre, including our research in progress sessions, where we really encourage you to both present, but also to give feedback to your peers during their presentations. You could start a journal club or contribute to your institute's journal club, where again, you're engaging in reviewing a paper and discussing that paper for its scientific integrity and merit. You can also, if you are attending the annual scientific meeting, engage in this while you are at the meeting. And this is something that we really, really want you to do, to be looking at each other's work, listening to each other's presentations, looking at the posters and saying, hey, I really like how you've done this. Have you thought about doing this? Or in India, we do things this way, and I see in Indonesia, you do them this way. Maybe we could think about cross-learning opportunities. Use it as an ability, use it as a platform to network and to build collaborative engagement as well.